After we write any piece of the application stack, whether it's front end, back end, whatever it is, we have to figure out what to do with it next. And typically in today's world, we're probably going to containerize it or maybe run it on a serverless function, whatever the case may be. But let's say we're thinking about containerizing it. We also have to think about, is this application going to break anything? And what do I mean by break something? I mean any type of security risk, okay? Are the libraries vulnerable? Is the base container image vulnerable? Was any type of static code analysis ran on the code itself or any SaaS-based solutions? So that's what we're going to do. We're going to learn how to containerize a Go app, and we're going to learn how to scan it for any vulnerabilities to make sure that it's ready for production. First things first, let's go ahead and take a look at the actual application itself. So this is a Go web-based API, and it's pretty small. So we have our package main here. We have a couple of imports that we're utilizing. This is going to be primarily because we're building a Go web API here. We're creating our own type. We're putting that into a struct, and it just contains a couple of keys. So name, title, state, all strings. We call upon our request one function because that's the function that's actually kicking off the Go web API. And then we have a couple of child functions in here. So this is just going to be some of the pages that are available. So one page, who am I, states a couple of different pieces of information here. This is calling upon the who am I type that we've created. As you can see, the endpoint will be who. And then as you can see here, each page is set up with its own path here based on the function, okay? And then it is being served on port 8081. So if we just go ahead and, for example, do a go build, all right, and then we run main, we can see that our application is now running. Okay, so the Go web app, we know it works, beautiful. So now what we want to do is we want to start kind of scanning this thing and making sure that it's as secure as possible before we do any types of pushes or anything like that. And there are a couple different ways that we can do this. You're primarily going to see two methods, SAST or DAST. SAST is like SAST, S-A-S-T, and it's pretty much static code analysis from a security perspective. So it just scans the code statically, meaning it's not currently running. DAST, it's the same thing. It's the same concept as SAST, except it's when code is already running. Okay, so you'll see DAST primarily in like a production environment that's already running. The code is running, the application is already running, and it's just dynamically scanning the code. And then you have something called SCA, S-C-A, Software Composition Analysis, and it scans the third-party libraries for vulnerabilities and license issues. So for example, I don't have any third-party libraries in this application. They're all libraries coming from the standard library within the language itself. We can still scan it just in case, but if I had a third-party library in here, yeah, I definitely want to utilize it. Now, there are a couple of different ways that we're going to scan. SNCC is probably the most used one. If I'm not mistaken, I even believe that the Docker scan, and well, it's Docker Scout now, it used to be Docker scan, but it uses SNCC on the back end. I don't know if it's still the case, but it at least used to be, okay? So what we would want to do is we'll want to first just scan our code. That's the preliminary, and then we will build the image, okay? So we could run SNCC code test. And as you can see, what it's doing is it's looking at all of the code within the current directory that I'm in. If I wanted to, I could also point to a current directory, or rather a directory that I'm not currently in. Okay, but as you can see, this ran successfully. Awesome, no issues were found. We could do the same thing with the SCA scanning or SCA. So SNCC test. I don't think I have to point it to go.mod, but let's see. Nope, I was actually able to pick it up for us automatically. Okay, so picked up the Go mod file. As you can see, everything looks good. Now we could also use SNCC monitor. SNCC monitor, it's the same thing, except it's going to continuously monitor within the SNCC dashboard any vulnerabilities. So it's kind of like DAST in a sense. And then we can of course add it to our CI test, which we're going to actually talk about as well in this video. All right, so as we can see, statically running everything manually, it looks good. Okay, so the next thing that we want to do is we want to containerize our application. How do we do that? Well, we have a Docker file. Okay, so within this Docker file, we have our base image, And then we have where the application is going to go, the build process, what port it's going to expose, and the application. This should actually probably be, well, you know what we'll do? We'll make a little bit of a code change here. Go into main, and I'll change this to 8080 because that's more of a HTTP level port anyways. All right, so as you can see, it's going to kick off the executable. How is it kicking off the executable? Well, same thing that we did, right? We ran our main configuration just now. The Docker file is doing the same thing because the go build command right here. So the go build command is building the executable, then the Docker file is running it. All right, so let's go ahead and do that. I have some instructions here. We're gonna run docker build -t, T stands for tag, and then I'm just gonna call it, I'm actually just gonna call it Go Web API, not Golang Web API. And then the dot indicates that I'm in a current directory with a Docker file. All right, as you can see, it's pulling everything that it needs to pull. And then once this is done, what we're gonna wanna do is, we're gonna wanna scan our container image. Now, a lot of the scan-based tools don't scan the Docker files directly. What they do instead is they scan the Docker image that exists based on the Docker file. All right, so we're gonna see how that's done. We'll use Snyk for that as well. We can also use Docker Scout. We'll see both here. Now, once that's complete, the cool thing that we can do is, you see this little what's next option? It's actually telling us, hey, do a quick Docker Scout. All right, so let's do that. Docker Scout quick view. Okay, now as we can see, we do have some vulnerabilities here. All right, so notice here, target, digest, base image, and then it's actually telling us what, I believe this is telling us what base image to use in this sense. So you can see view vulnerabilities, Docker Scout CVEs. Let's go ahead and run that. All right, and then it's letting us know a couple of lows here, 2 criticals. We could also scan recommendations. All right, and it's actually telling us, yeah, use that Go Alpine base image. Okay, so let's go ahead and do that then. Let's give it a shot. So I believe this image, if I scroll up here, what is this one right here? All right, so let's go ahead and check that out. Okay, beautiful. So what I'm gonna do is I'm going to Docker image ls. And then from here, what I'll do is I will copy this and I'll do Docker image rm. All right, beautiful. Then Docker image ls again. And we can see it's not there anymore. All right, so let's go ahead and do a build again. Actually, we'll do, again, same thing. I'm just gonna call it Go Web API. Now this is using the Alpine image. And then if we run Docker Scout quick view again, and by the way, I'm gonna show how to do this in a CI pipeline as well. All right, beautiful. And we can see our critical vulnerabilities went away. So now we know our container image, pretty good to go from a vulnerability perspective. We did 3 different types of scans on it. So now let's see what it looks like in a CI pipeline. All right, so this pipeline, I'm gonna give it a name, workflow dispatch. This essentially means it's gonna be a CI pipeline, but I'm gonna have a button to click instead of it automatically kicking off. Permissions just to read, it's not doing any type of write or anything like that. I'm gonna be using the Ubuntu latest runner. What does this mean? It's a container that runs the pipelines for us. You could also use your own if you wanted to, but these come directly from GitHub and are managed and maintained by GitHub, right? Shell, just using quick bash. And then for the steps, this is what's important here. So the first thing is I'm gonna check out the code to the pipeline. Next, I'm going to pull down the Snyk GitHub action. I'm going to authenticate because anytime that I'm using a CI pipeline with Snyk, I need to be able to authenticate. So I'm utilizing the token here. And then notice how I'm using the Snyk org. Now, if you sign up for Snyk, it's free. You could sign up. You'll be able to pull the token and the org from there, okay? So the first test that I'm doing, I'm running the software composition analysis with the Snyk test command. Then I'm running the SAS test with the Snyk code test command. And then from the pipeline, I am building the container image. I'm not pushing the container image anywhere. Notice here how I'm not pushing it. I'm literally just building it in the runner. And then once it's built, I'm running the snic container test command against it, okay? So with that, let's go ahead and run that. All right, we'll click on this and we'll wait for it to complete here. All right, and as we can see, the pipeline failed. Why is that? Well, notice here how everything was built. The SCA scan ran, we're all good there. The SAS scan ran, all good there. The container image was built. But then snic container runs, and notice here, tested 15 dependencies for known issues, no vulnerable paths. But it did find one issue, okay? And the issue was with no direct upgrade or patch, and it's just a medium severity. Now, here's the thing. Docker Scout didn't find this, I don't believe, but snic did, okay? So notice here how everything is all good, everything is all good, everything is all good. And it was just that one issue that occurred. So now at this point, you have to make a decision and say to yourself, okay, is this an actual issue for me or not? We could even notice here, use this subcommand, exclude base image vulnerabilities. I don't really know if I recommend that, but it's doable if you want to just remove this vulnerability. But pretty much at this point, because here's the thing, vulnerabilities are always going to scale different for an organization. A vulnerability that's high for me may be low for you and vice versa. So with that being said, at least you now know, okay, vulnerability exists. Should I do something about it or not? If it's not a big deal for you, don't do anything about it. If it is, obviously do something about it. This is going to be a team effort here with something like this. This is really where the threat modeling stuff comes into play. Threat modeling is really all about getting people in the same room and saying, this is the issue we have. What do you want to do about it? And that's how we can build, test, scan our container image both on the CLI and in a CI pipeline. Thank you so much for watching.